We also going to do some basic classification using TensorFlow. And so I'm going to start with importing TensorFlow, as well as importing the keras API right out of TensorFlow. Further, I need NumPy, and for visualization, I'm gonna import matplotlib. And so what we're gonna use as data set for classification will be the fashion MNIST dataset. That is a dataset that contains of 70,000 grayscale images in 10 categories of fashion, like clothes, shoes, and so on. And in correspondence to the traditional MNIST dataset that consists of digits, we do have grayscale images of the size 28 by 28 pixels. Okay, so we load this dataset. Let's call this fmnist. And here we see this is the fashion MNIST dataset. And now we're gonna put this into tuples for training and one more for testing. And so okay, so we can load the data. Oops. We can now load the data. And okay, so you might, when doing this for the first time, running this function for the first time, it's trying to download the fashion MNIST dataset, and I ran into an SSL-related problem doing this in Mac, and turns out there was a very simple workaround, because yeah, it basically was throwing me an SSL error, being not certified. So I Googled a bit to see what can be done about that, and this actually was the command that would actually do an upgrade on the certified library, and afterwards everything worked smoothly. Okay, so now we got our data, and now what we do is to define the class names. Let's classes for the data set. So this is t-shirt, and we have pants, and we got a pullover, and we get a dress, we got a coat, sandals, normal shirts, sneakers, get a bag, and finally we got boots. Okay, so let's take those as our classes, and now we can basically move on to explore the data a little bit. Okay, so let's see. What we do have is here is the separation into training and testing. So for training, we got 60,000 examples of 28 by 28 pixel images here put together as a tensor. And okay, so now let's use this loose matplotlib to actually illustrate and have a look. What am I doing here? So yep, let's take an example, out of the, so we can also, this is very interesting here, plotting this as a color image. Okay, so now let's do this. Okay, so you can see a dress plotted as a color image, grayscale. So this is what we want to classify. Let's have a look at a different one. Another dress, t-shirt, and the boot. Okay, so much for that. Okay, now what we need to do, as we've seen in our Hello World keras tutorial, is to scale the images, and therefore we're gonna divide them, and we're gonna do the same for testing images. And okay, so next thing we do, let's do a visualization that is pretty neat, with respect to also plotting the class names. So let's do 25, and now we can do a subplot of 5 by 5. This one. Oh. Oh, this is a tuple. Yep. Don't do any ticks here. Set grid to false. And now let's show. Now comes the interesting part of adding the classes. Okay, so we need just to check briefly something. Okay, so this is good. This is in the right order. Okay, so let's run this and see if this works. Oh, oops. Oh, what do we have here? Did I miss something? Oh, yeah. No. 1, 2, 3, 4, 5, 6, 9, 10. Yeah, it's fine. That's fine. That's fine. That's fine. Did I miss something? Oh, I did. Oh, here's the mistake. I accidentally didn't input the labels. I inputted the training data, so let's run this again. Okay, so here's what we wanted to have. Yeah, this is basically, as we can see, an overview with labels, right? So we got the t-shirt, okay, this is considered t-shirt, whatever. Pullover, sneaker. Yeah, this is actually, we should think in the original data set, this is, yeah, this is referred to as t-shirt and top. So, okay. Yep, we're gonna do this accordingly. This is t-shirt or top. Okay, let's go now to build our model. Let's build our keras model. And here we go. So model is quivered. And what do we get here? So again, this is to sequential, basically to say, okay, we want to do a stacked layer setup. And okay, so what we now can do is we got our keras layers, and now we're gonna flatten the input. And as input shape, we have 28 by 28 pixels. So again, we're gonna work, I'm saying again because we're kind of doing something like this in our Hello World with keras in R tutorial, working on the MNIST data set. We basically were flattening the input. So we were giving up on the spatial dimension. Since we were in this initial example and also here, we're not basically using convolutional nets. So activation function here in the first layer is going to be a ReLU function, and then we put an output layer here, and that uses a softmax function. So again, the output layer, dense layer with 10 output units, so this corresponds to our 10 classes. What might also be sometimes very nice is to do the following: number of classes is equivalent to n, and then basically we can say, okay, so this gives us obviously 10, and we can say, okay, the output should always be the number of classes. Now we can do something else here. We could say, okay, what is our width and height? This is also pretty neat if we want to go with, if we would like to go with a convolutional net, makes it easy as well. So we can do shape. So let's see how that's going to work out. We say mistake, my mistake. So, okay, that should have given us the 28 by 28. Okay, so now we can do this, right? So we got this automated a little bit, do not need to repeat or set this manually. Making this a little bit less error prone. Okay, so what do we get here in summary? So the first layer in our network, as I mentioned, does transform this 2D array into a 1-layer array of 28 by 28 pixels. And then, yeah, so basically what we then do is have a fully connected network. This is the layer dense, actually corresponds to densely connected or fully connected neural layers, right? So this first one has 28 hidden units, neurons nodes, whatever you call it, and the second one does have this 10 node output unit. Yep, so this is actually it. Okay, so now the next thing is to compile a model. So here what we're going to do is, yep, what's this giving me here? This is on. What is this giving me here? Wait a sec. Doing this. Yeah, here we go. Okay. And now we need an optimizer. Okay, let's go with the atom optimizer here. And next thing is a loss. Let's go with, how do we have this as well? Categorical cross entropy. And let's go as we did in our Hello World MNIST example. Let's go with accuracy. And now we're actually already, so you see it's like 3 lines actually. Now we can do a fit of this model. So this is actually pretty equivalent to, yeah, our other tutorial in R. And so what do we get here? Okay, so we get a different error here. Let's see. Spag, we get shape 1. Let's see. Let's check it twice. 3. What is this here? Oh, let's see. Interesting. Okay, yeah, so we needed, oh yeah, so we've been doing, we didn't set this to categorical, so here, let's go with this sparse categorical cross entropy. And let's do a model fit. So this is actually pretty interesting in the TensorFlow tutorial, and I have to check up on this one. This is not that familiar with this, so using categorical, and then, well, actually the sparse categorical, and I might get back to this later actually. Okay, so now we've trained our model, and yeah, now we can finally check our accuracy on evaluating the model. And let's check this. Oh, so this is actually not really nice. This doesn't look really good. Okay, we already had this in here, so there's an issue here. What's going on? It's not really training anything. Interesting. Let's rerun this. Let's see if we. Oh, maybe, let's see, yeah, I think we screwed it up along the way by potentially, by accident I was running this one multiple times, rescaling. Okay, so now we got that. And here we go. Okay, so this looks way better. Yes, so, okay. And now we're good. Okay. And yeah, I think I'm gonna look at, maybe in a later tutorial, we're gonna look at this difference between categorical cross entropy and sparse cross entropy. Yeah, so the only thing we know by, or I know by now actually, is that using sparse categorical cross entropy, we can actually skip this step of transforming or training labels into a one hot encoded array. And as you can see, so in our other Hello World example, we were actually doing this. Let me see if I still got this open. Keras intro, yeah, as you can see here, so once we're doing this in R, we were actually transforming this into a one-hot code representation. Yeah, to give you, maybe once we've got this open here, here's actually, as you can see, this is pretty similar. It's also built on keras here, the traditional MNIST dataset, and we basically do the same. We load the MNIST dataset, the digit dataset, and we build our sequential model. That's actually sort of the same shape that we have now, this densely connected network. Then we compile this, and since we here have transformed it, we go with categorical cross entropy and instead of sparse, and then we reshape our array again in order to build this tensor, to transform this tensor into this 2D array of having vectors per image, and then we transform this to categorical fitter network and evaluate it. So actually, as you can see, the rest is pretty similar. And actually, you know what? Let's see. I can actually run this. So this one is in R. Show you this. This one is in R. As opposed to, this might be green. So you get a comparison here of the syntax. And we are running this. And yeah, then it's basically doing pretty much the same. Okay, and one more epoch to go. Okay, and yeah, here we go. Okay, so this is it on this tutorial.